Hello and welcome to PSIRDEMATICA. In this video we would be looking at parallel programming. So this is the first of many videos in the series of parallel programming with C. So without wasting much time, let's get started. I'm Joseph Sedem, a tutor at PSIRDEMATICA. We are glad you are performing parallel programming with C with us. So before we start, we first have to get some assumptions straight. So for the purpose of better understanding, we would assume that one core or one CPU core in a multi-core CPU or in a multi-core processor, or that's in a shared system or shared memory system, would perform only one process at a time, or one CPU in a distributed system, so in a distributed memory system, would perform only one process at a time. That's to say that we can interchange the word process and processes in this series of videos. So when you hear the word process, you can pick it as though I'm referring to processes, because here we are assuming that one core or one processor does one process at a time or performs one process at a time. So at the end of this video we should know what parallel programming is. We should also know about some parallel programming APIs. Okay, now this set of videos would assume that you know a little bit about Linux operating system or you are using Linux. It doesn't matter if you are using Windows, let's say Windows 10 or Windows 11 going, you can install the Windows subsystem for Linux and then go and follow this video. And these videos or this set of videos also assumes that you know a little bit about C, the C programming, right? And then you also know about the concepts of parallel computing. But then if you don't know all these things, don't worry. PSIRDEMATICA has some videos on Linux here on YouTube, and then we also have another one on scientific computing with C, which teaches you how to use C programming language to do some scientific computations. And then we also have a video introducing you to the concepts of parallel computing. So if you know you don't understand what we call the shared memory system or distributed memory system, you don't know you don't understand the single instruction multiple data and these terminologies, then we advise you to go and watch this video, the introduction to parallel computing, here on YouTube before you come back here. Anyways, now what is parallel programming? So parallel programming is a process of decomposing a problem into smaller tasks. So you break down problems into sub-tasks that can be executed at the same time using multiple compute resources. So you decompose them into smaller tasks, and then these tasks will be executed. So the tasks in such a way that these tasks can be executed simultaneously on multiple compute resources. Okay, now the problem we have to look out for when performing parallel programming is first the parallel regions. So how do we determine the part or the portion of our codes that should be parallelized? So yes, you are writing a code and then you want to run some portions of this code simultaneously so that the answers will come, or you can get the results at the same time or faster. You have to look for the regions that you can write in a form that they can be executed simultaneously. The next one is the concurrency. So you'd have to look for a way to write these parallel codes or run these parallel codes such that they run at the same time, and then the serial side can continue running. So the concurrency has to be done in such a way that the parallel code, one portion won't finish running and be waiting for another portion before it continues. So this is also a problem, the problem of concurrency, how to make sure that the parallel portions run at the same time, and then the serial portion can continue running from there. And then we also have the process communication. That's if you are involving multiple processes or multiple processes, how can they communicate with each other? How would a processor 0 or a processor know that, okay, I'm supposed to send a data to this processor, and this processor would also be expecting the data from another processor, and all those things. You have to deal with the process communication. And then when you are done, look for a way to synchronize, put all the data or all the communication together. That's look for ways to put all of them together. So these are problems that we can't do, that we can't forgo, or that comes while dealing with parallel programming. So in order to minimize or reduce the intensity of these problems, we can use the parallel programming APIs, right? So an API is just basically an application program interface. So it's a program, but then it doesn't be written to the extent that you can just double click or you can just run, but then it has been written in such a way that you can incorporate some portions of that program into your code that you are writing, and then it will work. So some of these parallel programming APIs, we have the MPI, that's the message passing interface API. We also have the OpenMP, that's the Open Multiprocessing API. We also have the OpenCL, that's the Open Computing Language, the OpenGL, the Open Graphics Library, and then the NVIDIA CUDA. So the first two, that's the MPI and then the OpenMP, are CPU based. So they focus more on writing parallel codes that work with the CPU, right? That leverages the CPU. And then the OpenCL is more or less like heterogeneous computing, or the OpenGL and the NVIDIA CUDA focus on the GPU, that's the graphical processing unit. And since this series are focusing on parallel computing, that's parallel CPU computing, our APIs of interest are the MPI and then the OpenMP. Okay. Now, looking at the MPI, okay, the message passing interface, it is an API used for parallelism between processes in a distributed memory model. So which means that when you have separate systems, several systems, and each system has its processor and memory, each processor and memory, and these processes or these systems are connected together, right? And you want to let these systems communicate with each other, right, or run a code that will run on all those systems, then we use the MPI, that's a message passing interface. Okay, it is used for multiprocessing, bear in mind, multiprocessing, and then it is also used to create programs that run on multiple machines connected over a network. So basically that's for the MPI, right? That's MPI. Now when we come to the OpenMP API, now this is used for parallelism within a processor or a process in a shared memory model. So which means that here this time around, this is used for multi-threading, right? So we focus more on parallelizing processes in just a shared memory model. That's if you have one core or one CPU, right, which is sharing one memory, or which has a memory, how do you write a code that will perform separate things using or leveraging the multi-threading? Once again, if you don't know what multi-threading is, you can go to our video on scientific parallel computing and then learn about the multi-threading and other stuff for them. Now, this is also used for creating programs to be run on single machines with multiple cores, right? Single machines with multiple cores. So it means that you want to leverage the multi-threading. So this time we don't use the OpenMP to communicate within multiple systems like that are connected over a network, but rather we use the OpenMP API to create programs that will leverage the multi-threading capability of your CPU to run programs faster. So it means that this will also help you in parallel computing, but then this time around just within a machine. You are just writing a code that will be run on just a machine, your laptop or your desktop. Okay, so in the next video would be looking at message passing, how communication is done within multiple CPUs or multiple cores. Thank you.